Good morning, everybody. My name is Korra Kiran. Today, my subject is manufacturing process. Here, my topic is my topic is arc welding of structural alloys in steel. And here we can see that introduction to arc welding of structural alloy steels. Arc welding is a widely used method for joining structural alloy steels in construction and manufacturing. Arc welding is nothing but it is used of joining the structural alloys only for steels. For steel purpose, we can use the arc welding, and it is mainly for joining the structure and construction purpose we can use it. And it involves creating an electric arc between an electrodes and the steel surface to generate heat. This will happen electric arc between the electrodes and the steels. Between the steel and the electrode, it will generate some amount of heat which can join the structures, and this process ensure strong, durable, well suitable for load bearing structures and infrastructures. Actually, through this process, we can join the structures very strong. Durable welding is also have suitable loading also bearing the structures of the given structures. And here we can see that types of welding techniques. Here types of arc welding techniques we can see. Common techniques include shielded metal arc welding, gas metal arc welding, and submerged arc welding. Some of the types of arc welding, mainly SMAW, nothing but shielded metal arc welding, gas metal arc welding. These are types of arc welding techniques, and each method offers specific advantages based on the application, weld qualify, and productivity. Here this method are different application we can use it is because of based on the property and structure we can use these weldings, and selection depends on the steel type, thickness, and environment conditional of the welding site. This weldings are based on the thickness and environment conditions also will be occur in the welding. And properties of structural alloys steels. What are the properties we can see? Structural alloys steels contain elements like magnets and at the same time chlorine, and also magnets and chromium and nickel to improve strength and toughness. Especially the property like magnets, chromium, and nickel are it have mainly strength. It have more strength and density. At the same time, it have toughness more. That's the main thing of the using these properties. And also they are designed to withstand stress, fatigue, and corrosion in structural application. Corrosion means while the metals will occur corrosion based on their properties. Through that properties only we can do welding for not getting corrosion again. And another point is nothing but proper welding techniques are essential to maintain the mechanical properties of the steels. Based on the properties only, we can do the mechanically. We can have their properties at the same time. We have the proper welding applications also. We can use it. And here we can see that pre-welding preparation. What is the pre-welding preparation? Surface cleaning and removal of contaminants and critical to prevent defect in the weld. While we are doing the welding, we need to clean the surface because of for strong joining the structures or the given material, we need to clean and we get the there is no any defect on the metal also we need to see that. And proper fit up and joint design ensure optimal and weld quality and strength. And preheating may be necessary for thicker section or steels with a high carbon content to reduce thermal stresses. And welding parameters and controls, voltage, current, and travel speed must be careful controlled to achieve desired weld qualities. Mainly the parameters on the yielding, we can use that voltage we need to calculate accurately, and we can use that based on the welding application. At the same time, current, and we can give them travel speed must be carefully. And electrode selection influence that welds machines mechanical properties and corrosion resistance based on the electrode which we are selecting, that electrode which is used for the welding mechanical properties. Consistence and proper parameter setting minimizes defects such as porosity and cracks. While we are using the proper parameter, it will not have a defect like cracks in the metal. And welding consumable for alloys steels. Choice of electrodes or filler materials depends on the alloys composition and service conditions. Based on the alloys composition only, we can do the servicing, and they have different conditions also. And low hydrogen electrodes are often used to prevent hydrogen induced cracking. Because of low hydrogen electron, we can use in the welding, because of the corrosion will take less and cracking will also be not happen on the metal. Filler metals should match or exceed the strength and toughness requirement of the base steel. Here we can observe post weld heat treatment. Post weld heat treatment helps relieve residual stresses and improve toughness of the welded joint. It is PWHT is mainly helped for the jointing of the toughness improves of based on the stresses only it happen, and it reduces the risk of tributal fracture and hydrogen cracking in alloy steels. This will happen on the PWHT. The temperature and duration of PWHT depends on the steel grade and thickness. Based on the temperature and the different materials and different welding process have their grades. Based on the grades only, the temperature and durability will be occur. And common defects in arc welding of alloys steel. What are the defects we can see here? Mainly we can see with cracks will definitely one of the defect, such as compromise weld integrated also one type. At the same time, proper process control and inspection and essential to defect and minimize these issues. Through this, we need to control this defect. Just to, we need to do the inspection and essential for this issue. And another one is addressing root causes involves appropriate parameter settings and joint preparation. And inspection and quality assurance. Non-destructive testing methods like ultrasonic and radiographic testing verify weld integrity, and visual inspection assesses surface defects and weld geometric. Quality assurance ensure compliance with industry standard and safety equipment. While we are doing this inspection, we need to use that some of the non-destructive testing method like ultrasonic and radiogram. There are the one of the type. At the same time, defect also we need to avoid. Conclusion is, and best to practice successful arc welding of structural alloy steels requires proper planning techniques and inspection. Mainly we need to plan first of all. Based on the plan only we can execute the method. And understanding materials properties and selection suitable parameter improve weld performance. While we are doing the welding, we need to use the proper materials, at the same time suitable parameter. What are the parameter used for this application? By welding, through that only we can get good or improve the performance, and we can get good result while we are doing the joining the strong welding. And ongoing training and adherence to standard ensure durable, safe and reliable welded structures. This was, once we can recall what we have discussed now. Here we discussed that introduction to arc welding of structural introduction. Arc welding nothing but construction or joining any two structure of alloy steels. This is called, and based on the electrodes. And other type of welding is nothing but one of the shielded metal arc welding. Another one is gas metal arc welding and submerge. These are the type, and based on the application we can use this. At the same time, properties of the structural alloys mean nothing but elements like magnesium, chromium and nickel. They have strength and toughness. And pre-welding preparation means nothing but we need to clean the surface, and there is no any defect on the welding. And welding parameters are voltage, current and travel speed we discussed. Welding consumption of alloys nothing but several points have different electrodes often to prevent the including cracks. And post welded heat treatment is nothing but it have improved toughness of the weld joint, and risky brittle features like hydrogen and alloys will take place. And common defects are firstly main is crack, at the same time weld integrated. And inspection and quality enhancement nothing but we need to while we are doing this welding, any non destructive testing methods like ultrasonic or radiography testing, or we need to verify and we are avoid somewhat. Conclusion is nothing but we need to do with the help of planning and inspection. Based on the planning only we can go the welding performance, and we use proper parameter and materials which is required for that application we need to use. This must. Thank you.